Welcome to The Explainer. Today, we're going to get into the hidden science that honestly protects our entire future food supply. And it all boils down to this one tiny, incredibly powerful thing, a seed.
So you gotta ask, right? How long can a seed actually survive? Seems like a pretty simple question, doesn't it? But wow, the answer is what determines our ability to preserve, well, pretty much everything. We're talking about the food on our plates, the biodiversity of our entire planet. It's huge.
Scientists don't just wait and see. Of course not. They have a really precise term for this. It's called seed storage life. And what that means is the exact amount of time a seed can be stored before its ability to sprout, what they call its viability, drops to a certain level. So this isn't some vague idea. It's a hard number, measured in days, weeks, sometimes even centuries.
Okay, let's try an analogy to make this super clear. Think of a seed's life, its potential to grow. Think of it like a brand new, fully charged battery. Right when it comes off the plant, it's at 100%. But over time, that charge, that life force, it just slowly drains away. And how fast it drains depends completely on the conditions it's stored in. So what drains that battery the fastest? Well, a seed basically has two main arch enemies: temperature and moisture. Yeah, how hot it is and how much water is inside the seed itself. Those two things are the absolute keys to whether it survives or not. So how do we actually talk about a seed's lifespan? Turns out there are two really different ways to go about it. You can use words or you can use numbers. And you can see the difference right here. It's pretty stark. On one hand, you've got the qualitative approach. You could call it the feeling. It's based on observation, You'd say something like, this seed lasts longer, which is helpful, but it's kind of vague. But then, on the other hand, you have the quantitative approach, the fact. This is all about hard measurement. It gives you precise data, like this seed's viability will be 60% in exactly 3 years. Now that's the kind of precision you need for, serious conservation work. Okay, but before we dive headfirst into the really complex math, there's a fantastic little guideline for getting a quick estimate. It's called Harrington's Rule of Thumb, and honestly, it's surprisingly effective. All right, so check this out. Here's how it works. If you increase the storage temperature by just 5 degrees Celsius, that simple change cuts the seed's potential lifespan in half, just like that. It's an incredible illustration of just how sensitive these tiny living things are. A teeny tiny change in their environment has a massive impact. And hey, the reverse is also true, which is where things get really powerful and frankly, a lot more useful. If you can drop the temperature by those same 5 degrees, you can actually double the seed's storage life. I mean, how cool is that? Simple, effective, and a total game changer for preservation. And get this, it's not just about temperature. The exact same rule applies to moisture. Just a 1% increase in the seed's water content, it'll cut its lifespan in half. Decrease it by 1%, and you double it. It is that sensitive. But, and this is a really big but, this handy little rule isn't some kind of magic bullet. It definitely has its limits. It really only works within a pretty specific temperature and moisture range. You go outside of that, and the predictions just kind of fall apart. And remember, it's a rule of thumb, not a law of physics. So it's not going to be perfectly accurate for every single species out there. So for the really critical work, I'm talking about preserving global biodiversity and massive seed banks. A rule of thumb just isn't going to cut it. We have to level up. We need the pure precision of mathematics. And here's what that precision looks like. Yeah, I know an equation, but stick with me. Scientists like Roberts and Ellis came up with these incredible formulas. The best way to think of it is like a predictive recipe. It takes the temperature, which is T, the moisture, M, and it plugs them in with a few other key numbers to calculate a seed's lifespan with honestly amazing accuracy. So what are those other key numbers I just mentioned? Well, they're called constants. And they are a set of totally unique numbers that describe exactly how one specific species ages. Every single plant species has its own set of constants. It's basically its own secret code for survival. Let's make this real with an example. Okay, look at this table. It shows the unique constants for 3 totally different plants: barley, onion, and soybean. See how the numbers next to Ke, Cw, Ch, and Cq are different for each one? That's the secret code I was talking about. By plugging these specific numbers into that formula, scientists can get a much more accurate prediction of how long each of those seeds will last in any given environment.
So, all this complex math, why does it actually matter? Well, because it's how we go from an abstract formula on a page to a powerful, real-world tool that honestly protects every single one of us.
Yeah, this isn't just theory that's locked away in some lab. We're talking about global seed banks, like the world-famous Royal Botanical Gardens at Kew in the UK. They use these exact equations every single day. They absolutely rely on this math to manage their priceless, completely irreplaceable collections of seeds from all over the globe.
And what's at stake here is just enormous. This work is absolutely vital. I mean, it is the foundation of our global food security, making sure we have seeds for the crops of the future. It's our best shot at saving countless plant species from going extinct, and it gives us the raw materials, the resilience that we desperately need to face these huge future challenges like climate change. So the next time you hold a simple seed in your hand, maybe from an apple or something you're about to plant, just take a second to remember the incredibly complex science and the huge global effort that is dedicated to protecting its potential. And that leaves us with one final crucial question to chew on. What is the true value of a seed that can wait?